Thanks everyone for coming. Today I'm just going to talk a little bit about landfill monitoring and why it's important. So during the presentation I'll just go through landfills, a little bit of history and siting and activities, a little bit about the importance of environmental monitoring, some of the regulatory obligations of landfill owners in terms of in relation to monitoring and reporting, and just some examples of how monitoring assists better landfill management. Okay, landfills have historically been the most common method of organised waste disposal, typically situated in low-lying areas such as wetlands or old quarries. They represent the oldest form of waste management, dating back to Stone Age middens and early human settlements. Often the most cost-efficient method, especially when you're just sort of backfilling an existing hole. And sometimes it's used also as a method for land reclamation. I mean, the common types of landfills are things like the municipal landfills, which sort of generally accept waste which has been generated by the community. But less common are also repositories for hazardous and industrial wastes. Some of the older landfills probably also contain hazardous materials because in the olden days they were very poorly monitored, so not much control was given to what was actually being put in the landfill. So a lot of the older landfills can almost be regarded as hazardous landfills as well. All right. Sorry about that. All right. I mean, this is just like an example of modern landfill. This is just a pit being filled. I mean, in these modern landfills, you've sort of got the lining on the sides there. You'll have a leachate collection on the sides, on the bottom, and some of these older ones will also have gas extraction occurring. Okay. All right. Due to the main aims of the waste management hierarchy is actually to try and reduce the amount of waste going to landfill. I mean, many of the talks you'll be hearing at the conference over the next couple of days will be concentrating on the first 4 points on that diagram. Okay. And the policy by government's also been set to actually try and reduce the amount going to landfill via use of levies and to try and help reuse and recycle of material before it gets to landfill. Although the resource recovery now is about 60%, through reuse and recycling, the amount produced per person has been steadily increasing, and the resulting amount going to landfill remains significant at about sort of 20 million tonnes per year. And even after a landfill has been closed, it will sort of represent a potential source of pollution for many years after it's closed. Okay, the Australian Bureau of Statistics shows that about 19 million tonnes of waste is sent to landfill in 2011, equating to about 880 kilos per person. Recent data corroborates this, in that approximately 20 million tonnes is going to landfill, and that sort of equates to 830 kilograms per person. So even though we're sort of getting better at recycling and recovery, I mean, because we're having a bigger population, there's still significant amounts of waste going to landfill. 72% of the volume is concentrated in New South Wales, Queensland and Victoria. The total number of active landfills in Australia is probably more than 600, but it could be up to 1,000 if sort of including sort of smaller landfills that are sort of unlicensed or are not sort of not being covered by licences. And also the other thing is also that there are about 116 current landfills in Australia accepting more than 20,000 tonnes per year. This represents 95% of the total mass being sent to landfills, and I mean, some of the advantages of this is that it sort of makes it a lot easier for people to recycle and recover, and you've got less sites where you have a potential for contamination to occur. The main sort of one of the main components going to landfill is putrescible waste, and it's a solid waste containing organic matter. Once it hits the landfill, the organic matter starts degrading, and when you're doing landfill monitoring, you're targeting some of the products of this degradation. So you're trying to sort of target things like the methane, ammonia, and then sort of nitrate. Also things like fatty acids and odours, which are caused by some of these butyric acid and propionic acid, and also alkalinity, which are sort of all markers for landfill contamination. Okay, just look at some of the processes that occur when you sort of the main stuff going in is made up of proteins, carbohydrates and fats. That's always broken down to these components, and you're looking for, as amino acids are broken down to acetic acid, you get ammonia coming off here, so that's one of the products. Some of these intermediates here are propionic acid and butyric acid. These are sort of what gives a lot of the odours within a lot of the odours you get coming off landfills. And at the bottom here you get the final product is methane, and so there's also CO2 produced as well, and once the CO2 dissolves in water you get alkalinity occurring, so you're looking for that as well. But when you're actually monitoring, you're actually looking for a lot more than just those analytes, and so you're looking for things like sort of organic hydrocarbons and heavy metals as well, and that can be from other components which have been landfilled. So as a definition of environmental monitoring, so it's a systematic sampling of air, water and soil and biota in order to observe and study the environment. The monitoring can be conducted for a number of purposes, including you want to establish an environmental baseline of trends to see whether the landfills actually have an impact on the environment. You want to be testing environmental modelling processes, maybe. It can also be used for education of the public about environmental conditions, so whether you are actually having impact or not. It can inform policy design and decision making, whether you're going to do more monitoring or less monitoring, whether you need to have more monitoring points around your landfill. It can ensure compliance with environmental regulations, and it's assessment of the effects of anthropogenic influences. So you want to compare what you're getting around the landfill to a baseline upgrading of the landfill. And environmental monitoring programs can vary significantly in scale, in scale of their spatial and temporal boundaries. I mean, an example of that would be sort of atmospheric monitoring of CO2, which giving you sort of in greenhouse gases monitoring. All right, some of the challenges in monitoring around landfills is actually trying to separate the impacts of the landfill from the impacts associated with other local or regional influences. And a lot of the problems also occur because there's usually a lack of baseline background data. There's usually no data from before the landfill commenced. There's also inadequate monitoring, and there might be an inadequate number of actual monitoring points. There could be also poor monitoring or monitoring point construction or location, and there's also sometimes there's missing data. Like so things have actually been constructed around the landfill, but there's no data telling you how it was constructed or what's actually or what you're actually measuring. So you don't know where the samples are coming from at all. An example for that is groundwater bores. If you don't know where the bores are screened, you don't know where the groundwater is coming from. Okay, and so the challenge is to identify the impacts arising from the landfill versus the impacts arising from things happening around the landfill. Okay, and the key to this is always trying to find appropriate background monitoring points. So if you've got groundwater bores, you need to place the groundwater bores upgrade into the landfill so that you can measure a background value and you can measure downgrade into the landfill to try and sort of see whether the landfill's actually done something or affected the groundwater or is affecting the groundwater. So this is a little bit more about that sort of stuff. So in this case here, you've got some landfill gas bores on this side. So even though the landfill gas is being extracted from this landfill, there's still a possibility that some gas is escaping from the landfill, and these bores are placed. These would normally be placed right around the landfill. The density of those would depend on what sort of geology you have around the landfill. So if you're in a sandy geology, you'd probably put more of these around the landfill, and in a sort of a very heavy clay, you'd put less around the landfill. These things would also have slotted screens all the way down to the base of the landfill, so that any gas that's coming across comes up and can be detected in these detected up here. The other sort of main monitoring sort of things you would use would be the groundwater wells. There's those ones there. So they would sort of extend down into the groundwater below the landfill, and you would place these. You'd place some up gradient, so the groundwater. So if the groundwater is flowing, if the groundwater is flowing across this way, you would place upgrading ones up here, and then you'd place downgrading wells on this side, and you'd be looking at changes in the chemistry between this monitoring well and this monitoring well on that side. Okay. And then the leachate wells, you'd be looking for any seepage, even though you have got a lining on the landfill here. There's still a possibility that lining is broken, and there's still a possibility that leachate might escape from that. So you need to have leachate monitoring wells here as well. Let's talk a little bit about the regulations here in New South Wales and in Victoria, and how they sort of pertain to monitoring. I mean, these are the guidelines, the New South Wales guidelines. I mean, they're sort of set up, they sort of come in two parts. They have like a general information type at the beginning, and they have in the part B they've got a whole range of minimum standards. Couple minutes. Okay. All right. But what they do is also they talk a lot about. They'll also tell you about water quality monitoring and how to manage and monitor landfill gas. And we have the BEPM in Victoria is similar. They have like a general they've got a general section at the top, at the beginning, and then they've got a more detailed section following where they talk more about they'll talk about things like sort of landfill gas generation and design of landfill gas monitoring bore systems. Okay. All right, I'll just quickly move on to a few case examples we've got. Okay, so this is some work we've done for net waste regional councils. It's a sort of voluntary waste group formed in 1995. There's 25 councils, or 26 councils I heard today actually, that's actually more. And it's sort of, in 2012, we were awarded a contract to actually conduct the sampling for these guys. We sort of had some of the 5 councils were Blaney, Dubbo, Forbes, Narromine Parks. And recently we sort of started also doing some work for Lithgow City Council as well. So just to give you a bit of the region sort of, this is the net waste councils. They cover an area of about 40% of New South Wales. We were doing work for some of these councils around here. Okay, so looking at these councils had a number of groundwater, surface water and landfill gas sampling points. They had 4 to 6 groundwater points. Surface water is a lot less, except for sort of Dubbo's got quite a few ponds on site, so they've got more points to measure. Dubbo is the only sort of site that actually had to do landfill gas monitoring. All the other 2 sites just had on-site buildings that had to be monitored. They were 4 actually subsurface sites that had to be done, and Parks was the only one that had to actually have any dust samples taken. I'll just skip that actually. What we did do here was so what we did for these guys was actually through some of the results we got through our monitoring, we were able to sort of reduce the amount of sampling they had to do. We looked at the groundwater depth and receptors away from the landfill, and we negotiated with the EPA to actually get the reduction of sampling for parks down from a monthly groundwater to biannual, but we were unable to actually alter any dust sampling frequency because the dust results were always sort of very variable and above the guidelines. We were arguing that looking at the site, there's a lot of we were sort of arguing that the dust could easily be coming off-site as compared to even on-site. if you look at all the sort of area around the landfill, it's all farmland. It could easily be producing a lot of dust itself, but we couldn't really prove that it was coming from off-site, so the UK wouldn't accept that argument. About that. Just to finish up. Oh, no, not that one. I mean, the reason why it's important, landfill monitoring is important, is to actually build up a database of baseline operational and post-closure data, which can be used to assess compliance with licence requirements and guidelines. It can also be used to assess whether monitoring frequency criteria or location or number of monitoring points are adequate. It can also be used to whether the landfill is actually adversely impacting the surrounding environment, whether impacts are from the landfill or other local regional influences, and whether we need any further action, ultimately to ensure that the safety and amenity of the environment. Thank you.